Today, we're diving into one of the most secretive and potentially game-changing weapons in modern aerial warfare. Welcome back to WarTech Vanguard. For years, the United States has quietly been developing a missile designed to dominate future air combat. But here's the shocking part. This weapon is reportedly designed to outrange, outsmart, and outfight almost every air-to-air missile currently known in the world. If deployed at full capability, it could allow American fighter jets to destroy enemy aircraft long before they even know they're being targeted. And that weapon is the AIM-260 Joint Advanced Tactical Missile, also known as JATM. Before we continue, if you love deep dives into cutting-edge military technology, stealth fighters, and next-generation weapons, make sure you stay tuned because today's breakdown will reveal why many defense analysts believe this missile could redefine air superiority for the coming decade. The AIM-260 JATM was developed by the United States primarily to replace or supplement the long-serving AIM-120 AMRAAM. According to information released by the US Air Force and the US Department of Defense, the program began because potential adversaries were fielding longer-range air-to-air missiles, particularly China's PL-15 missile. Sources such as reports from the US Congressional Research Service and Air Force magazine explain that the AIM-260 program aims to restore the range advantage of American fighter aircraft. The missile is designed specifically to operate with the F-22 Raptor and F-35 Lightning II, the two most advanced stealth fighters in the US inventory. Externally, the AIM-260 JATM is intentionally designed to be similar in size to the AIM-120 AMRAAM. This design decision is important because it allows the missile to fit inside the internal weapon bays of stealth aircraft. According to statements referenced by Air Force acquisition officials and coverage from Defense News, maintaining compatibility with the existing weapon bays of the F-22 and F-35 ensures the aircraft can carry the missile without compromising stealth by mounting weapons externally. The missile's shape is expected to feature optimized aerodynamic surfaces, low drag control fins, and advanced composite materials that help it maintain high speeds while minimizing radar signature. While many technical details remain classified, analysts note that the external design prioritizes long-range stability and efficient high-altitude flight. Inside the missile, the internal systems are where the real technological leap happens. The guidance system reportedly integrates advanced active radar homing technology combined with improved onboard processing power. According to defense analysis from Janes and Air Force magazine, the missile is expected to use upgraded seeker technology capable of resisting electronic jamming and tracking highly maneuverable targets. The internal electronics also support network targeting, meaning the missile may receive updates from the launching aircraft or other sensors during flight. This capability allows it to adjust its trajectory dynamically if the target changes direction or attempts escape. Performance is where the AIM-260 becomes especially interesting. The exact specifications remain classified, and the US Department of Defense has not publicly confirmed the precise range or speed. However, credible defense analysis from Air Force magazine and the Center for Strategic and International Studies CSIS indicates the missile is designed to significantly exceed the range of the AIM-120D AMRAAM. The AIM-120D is widely estimated by analysts to have a range of roughly 160 kilometers, although exact numbers are classified. The AIM-260 is believed to extend beyond this, allowing American fighters to engage enemy aircraft from farther distances. I cannot confirm the exact range figure because the US military has not publicly released it. What is confirmed is that the missile's purpose is to counter long-range threats such as China's PL-15 missile and ensure US fighters maintain a first-shot advantage, a concept widely discussed in air combat doctrine. Speed is another factor contributing to its lethal capability. Long-range air-to-air missiles typically travel at speeds exceeding Mach 4, according to aerospace defense references from Raytheon and NATO missile documentation. While the official top speed of the AIM 260 has not been publicly disclosed, analysts expect comparable or greater performance. High speed combined with long range drastically reduces the time an enemy aircraft has to detect, evade, or deploy countermeasures. Safety features in advanced air-to-air missiles are extremely important because they operate in complex combat environments with friendly aircraft nearby. According to information from US military weapons safety documentation, modern missiles include multi-stage arming systems that prevent detonation until the missile is safely launched and reaches a safe distance from the aircraft. The AIM 260 is expected to incorporate similar safety mechanisms, including secure electronic arming, target discrimination algorithms, and controlled proximity detonation. These systems reduce the risk of accidental detonation and help ensure the warhead only activates when a verified target is within lethal range. Another important safety aspect involves communication security. Modern missiles use encrypted data links to communicate with the launching aircraft or battle network. Defense publications such as Jane's Defense Weekly report that next-generation missiles like the AIM 260 are designed with advanced electronic countermeasure capabilities. This means they can resist attempts by enemy aircraft to jam, deceive, or disrupt their guidance signals. These safeguards ensure that the missile remains on course even in heavily contested electronic warfare environments. Now let's talk about what makes this missile truly unique. One of the biggest selling points of the AIM 260 is its integration with stealth fighters and advanced sensor networks. The F-22 and F-35 operate as part of a networked battlefield where multiple aircraft, satellites, and radar systems share targeting data. According to analysis from the US Air Force and CCZAS, the missile can take advantage of this network to receive mid-course guidance updates. That means the launching fighter may not need to keep its radar locked on the target throughout the entire engagement. Instead, another aircraft or sensor system could help guide the missile during its flight. Another unique advantage is stealth compatibility. Many long-range missiles are physically large and cannot be carried internally by stealth fighters. By keeping the AIM 260 similar in size to the AIM 120, engineers ensured that stealth aircraft could carry multiple missiles while remaining radar invisible. In modern air combat, maintaining stealth is critical because being detected first can mean losing the engagement. There is also strong speculation among defense analysts that the missile incorporates advanced propulsion or energy management techniques to extend range. However, the US Department of Defense has not publicly confirmed the specific propulsion technology used. Because of this, I cannot verify whether the missile uses a dual-pulse rocket motor or another propulsion system. What can be confirmed from official statements is that the program's primary goal is to achieve longer engagement distances while fitting inside existing fighter weapon bays. Now let's address one of the most common questions viewers ask. How much does this missile cost? Unfortunately, the exact unit price of the AIM 260 has not been publicly released. Defense procurement programs often keep these figures classified until production scales up. However, we can estimate context by comparing with the AIM 120D. According to the US Department of Defense selected acquisition reports, the AIM 120D has historically been estimated at roughly around $1 to $1.05 million per missile, depending on production, batch, and configuration. Because the AIM 260 contains newer technology and advanced electronics, analysts expect the price to be equal or higher, but I cannot confirm a precise figure due to the absence of official public data. Production and deployment timelines also matter. Reports from Defense News and Air Force magazine indicate that the AIM 260 program reached key development milestones in the early 2020s. The US Air Force originally planned for initial operational capability around the mid-20s. As we move toward the 2026-2027 timeframe, this missile is expected to begin replacing or supplementing AMRAAM missiles on frontline fighters, giving aircraft like the F-22 and F-35 a new long-range strike capability against enemy aircraft. Imagine a future air battle where stealth fighters detect opponents hundreds of kilometers away through a network of sensors. Before the enemy pilots even know they are being tracked, a missile launches silently from inside a stealth fighter's weapons bay. Traveling at hypersonic-like speeds, guided by advanced radar and secure data links, it closes the distance in seconds. By the time the target receives a warning, it may already be too late to escape. That concept, striking first from the longest possible range, is exactly what the AIM 260 program was designed to achieve. So what does this mean for the balance of air power? Military strategists emphasize that air superiority has always depended on detection range, missile range, and pilot awareness. According to studies from the RAND Corporation, modern air combat increasingly favors the aircraft that can shoot first while remaining undetected. By extending missile range and improving electronic resistance, the AIM 260 could significantly strengthen the combat effectiveness of American stealth fighters in contested airspace. As we wrap up today's deep dive on Wartech Vanguard, the AIM 260 Joint Advanced Tactical Missile represents more than just a new weapon. It represents the next evolution of aerial combat strategy. A missile built for stealth fighters, designed to outrange rivals, equipped with advanced sensors and electronic protection, and integrated into a networked battlefield. While many of its secrets remain classified, the information confirmed by defense officials and credible analysts suggests it could become one of the most powerful air-to-air missiles ever deployed. If you found this breakdown valuable and want more detailed explanations of next-generation military technology, stealth aircraft, and advanced weapons systems, stay connected with Wartech Vanguard.